Right, first question. When will a datagram packet switch network be faster to use than a virtual circuit switch? First, which one is faster? Forget about this question. Another question. Which one is faster? Virtual circuit or a datagram switching technique?
I think datagram.
You think datagram. Why? Or well, go on. Forget the why.
The header is shorter in the virtual circuit. So
It has a smaller header. That I don't know if it affects speed. It might affect requirements on memory.
Okay.
Speed. Which one is faster? Which one do you think is faster? A datagram switching technique? A virtual circuit?
Datagram. It doesn't have to wait for the device to accept it.
Right, okay. The speed, let's say the speed of the links are the same. So which one is faster? We have the same machines, the same channels, the same speed. Now, which one would you use for speed? I have a message to send and I wanted to get there as fast as possible. Yes, datagram. Who said datagram? Everybody said datagram? Why? Why is virtual circuit not faster? Why is datagram faster?
no, because it just goes. It hits the road and just goes.
It just goes. Because, you mean it doesn't involve a call request?
Yes.
Okay. Anybody thinks virtual circuit's faster? Yeah?
I think virtual circuit's faster because the datagram could get clogged up with too many users.
It could get clogged up with too many users. But if at the moment it's okay, would you use it? Okay, let me ask you another question. It's just to help answer this question. You have a message. I'm going to send a friend of mine in Australia a message. I'm just going to say, hi. That's all. One word. Which one would you use? Which technique would you use? Datagram? Why?
Because you need a confirmation of the user.
Okay. Forget about confirmation. I'm worried about speed. I just wanted to get there as soon as possible.
Because you can take different routes. So if one route is busy, then you can redirect it to another route.
Yeah, so, okay.
But I don't
But
think
same with the virtual circuit. If it looks for routes, and if this one is busy, it will pick me another route.
but in virtual circuit, I think there is a route dedicated for every code.
No, it's indicated at the start. No, not necessarily. If I make a call from here to Australia, a virtual circuit, and I'm given a route, tomorrow it could be a different route. The virtual circuit, when you make that call, it looks for the best route at the moment you make that call, but it will remain constant for the duration of that call. Anybody else? Right, let me put another question. It might help answer this. I have a video, a big file, 1 gigabyte. I want to send it to my friend in Australia. Which one will be faster to download that file? Virtual circuit.
To get a good of quality.
Okay, good quality. Right, but it's more likely to remain good for a long time. The datagram may not remain good for an hour or whatever it takes. So maybe for big messages, it might be a good idea to use virtual circuit. But for short message, one word. Remember, with virtual circuit, you must first send a call request. So by the time you send the call request doesn't have any advantages. It's going to go like an ordinary packet. When it gets there and comes back, then now we have that advantage sending. But if it's only one packet I'm sending, short message, I can use datagram. By the time I send my message, the virtual circuit, they've just sent their request and they're waiting for their response. So basically, generally, datagram might be faster for short messages. But for long messages, it's no guarantee that it will remain fast. Even if it's fast now, it can probably go slow. But with virtual circuit, because it's a long period of time, it's a big message, the call setup becomes insignificant compared to the length of the time. So maybe for larger messages, virtual circuit might be the better use or the better option. So that's if you're looking for speed. Now, if I'm looking for confirmation and definite, and I want to make sure good quality, that's another question. But speed is different. So if we're looking for speed, it might be faster for short messages to use datagram, and it might be faster for longer messages to use virtual circuits. Now, is a datagram switch network better, or is virtual circuit switch network better for user to watch a streamed video? Virtual circuit. Why? The answer is always easy, this one or this one. The reason. Why is virtual circuit better? Do you remember? Are you with us? Yeah? The size of the video is the same. The capacity of the network is the same. Why is it better to use virtual circuit? It guarantees the quality of service. Virtual circuit will guarantee you a good quality. It will not fall below a certain level. So if you're watching lots of data for a long time, especially the kind of data, like if you're sending lots of emails, it doesn't matter if you're delayed 5 seconds or 10 seconds because it's not live. You don't want to see it there and then. With email, it doesn't matter. But if the material you're sending, it requires high quality, good quality, like a video or music. I mean, music especially. You don't want to hear music and then stops and then, it goes on and off. Annoying, especially, again, music and videos. So those music and videos, you always want good quality. So if you're ever asked about video, automatically it means we are looking for good quality, for guaranteed quality, and that's virtual circuit is the only one that guarantees quality. Which switching technique has the larger header, which probably will cost us more and put more requirements? The datagram. It has the source address and destination address on every packet. Like if you have a file, a video, and you want to break it into packets, you probably break it into 1 million packets. You're going to be adding 1 million headers, 1 million addresses. The IP address, does anybody know how big the IP address is? 32 bits or 64 bits or 128 bits. So one address is 128 bits. It's huge, and you have to have 2 of them on every packet. So that can be a lot of cost, a lot of redundant information. Which technique can block new calls? Hold on. Thank you. I'll pick my students. Anybody here can tell me which technique can block a caller? Circuit switching or virtual circuit or datagram? Circuit switching will definitely block you. That's the old telephone. Whenever you think of circuit switching, think of the old phones. Whenever you want to think about datagrams, think of the postal system. Whenever you want to talk about virtual circuit, think about booking a flight. Well, that's the nearest anyway. So to help you, with booking flight, you may be turned down. You might be told, sorry, the flights are full. So that's virtual circuit. You might be told, see why it guarantees a good service. For example, if the router can handle 10,000 calls and it already has 10,000 calls and you want to put another call, it will tell you, no, I'll block you. It will guarantee a good service to those 10,000 existing users. With the datagram, it does not block anybody. And therefore, there's no guarantee for that good service. Right, I won't skip this. I'll skip this question. In which technique do packets get reassembled into a message which will hopefully match the message sent by the sender? So if you have a message, you break it into small packets, send it at the other end, put it together into the same original message, hopefully, and hand it to the final user. Which technique does that? Breaks a message into packets. Any idea? Both. So they all do it. The circuit switching, remember with the old telephone systems, it doesn't require you to break any messages. The circuit switching connects your computer to the other computer in Australia as if it's on a direct connection. If you want to break your message into packets, which usually computers do, but it's not a requirement for the circuit switching. So probably they do break the packets as well, but it's not a requirement. But on the datagram, you must break your message into smaller packets. On virtual circuit, you also must break the message into smaller packets. And then at the other end, put them together, hand the picture or whatever it is to the final user. Which technique directly supports the implementation of an internet protocol? Which one is more suited for the internet? The datagram. It's designed for it. It's 100% designed for it. And remember, just let me point something out. The internet, they realized it's not a good idea not to have error detection, not to have acknowledgement on the original internet. I'm talking about the original internet. So what they did, they added in an extra service later on to the internet, and it's called TCP. So we'll talk about it later on. But TCP is something on top of the IP, they call it TCP IP, and that gives this extra functionality. If you want to have acknowledgement, then start using this. But it's not part of the network. It's part of your end devices, the receiver and the final machine, or the sender and the receiver. It's only done acknowledgement between the first machine and last machine, not at every router. With the circuit switching, you deliver it to the next machine. They say, hold on. Oh, yeah, we got it. That's fine. Then send it to the next machine. And if it doesn't reach there, it'll ask the previous one to confirm it and send it again. So it's done at every step of the way. While with the internet, they introduced this facility, but it's only done from one end to the final end. After the entire message is delivered, we check it for error. Sometimes, it's too late, like it traveled so far, so long, and then you discover the error. But we'll talk about this again later. But for now, the datagram switching technique does not, as far as we're concerned, it does not provide error detection. Which technique do successive packets, the packets or the datagrams that travel from the same sender to the same destination, may follow different routes? In datagram, they may follow different routes. They may go on the same route as well. But in virtual circuit, they definitely must follow the same route. Okay, I don't think you have any problem. It's good. I'm delighted. I'm getting a good response. So I want you to have a look at this. Has everybody signed the attendance sheet? Would you mind writing me the date here somewhere, please? At the top. Anywhere. There. Is that? Yeah.
We talk about headers, longer headers. In the virtual circuit, they also use the header, and they use sender and address, and with the reference number.
Only on the first packet, only.
Oh, and the other one is
on the others, only the booking code, or what we call the virtual circuit number.
So that's
Okay.
why the data
it's more efficient, slightly more efficient, because it has smaller header. Okay, the question is about the header used on virtual circuits and on datagram switching technique. Do they all have addresses? On datagram switching techniques, all packets will carry a header that carry the source and destination address. On virtual circuit, only the first packet that carries the request has the addresses. The rest of the packets, they only carry the code, that virtual circuit number. Okay, I don't know if I have enough, so if you can share, guys, can you share one? This is your first tutorial, and I'll expect your answers on Moodle. But you can go through the questions now and see if you have any question. You can discuss it with your mate beside you, and if you share this, start with you. Right. If you're sending lots of data, would you use the datagram switching technique? Would it be better to use the datagram switching technique or the virtual switching technique if you're sending a message or downloading a long video?
Video?
Yeah.
Because virtual circuit.
Why?
Because the quality, we guarantee the quality of.
Because it guarantees the quality of service. How does virtual circuit switching technique guarantee a good quality of service? Dedicated link? No, there's no dedicated link. What switching technique uses a dedicated link? What? Hold on, guys. I'll pick the. I only want one volunteer. You're volunteering now. Circuit switching technique is the only technique that uses dedicated cables or dedicated links. Okay, so virtual circuit does not. So how does virtual circuit switching technique still guarantees a good quality, yet it does not use dedicated links. Any idea?
How does
The virtual circuit switching technique can guarantee a good quality.
it only allows
Specific number of users.
number of users. Exactly.
Okay, because it can block new users in order to guarantee good quality for existing users. Which switching technique is better? Virtual circuit switching technique or datagram switching technique?
Better.
Yeah, which one is better?
Virtual, because it's got a better quality.
Not right answer.
For big message, I would say virtual. It is short message.
Okay, so in some cases, there's not one of them is better than the other. In some cases, virtual circuit is better. In other cases, datagram switching is. Okay. Right, which of the switching techniques uses the links a lot more efficiently? That means most of the time the link is busy to its full capacity or close to its full capacity. Which one of those has a higher percentage of usage or utilization? Hold on. Anybody on this side? Yeah?
The datagram.
The datagram. Why?
Yeah, because it chooses a specific path for a specific data.
For the message.
Yes.
But so does the datagram switching, the virtual circuit switching technique also uses a particular path. Any other reason? Hold on, I have somebody here, I have a volunteer.
If the datagram gets too clogged up, it chooses the best way, so it's using most of the different lines at one time.
Okay. It's because, yes, another reason? Yeah. Let me just voice out what the answer is, because it's a correct answer. One of the reasons is that datagram switching technique will always tend to go to a less used line and utilizes it. So that's one part of the answer, but that's being flexible at routing. What's your answer?
It's because there's no restriction. Everything just clogs. It just hits the highway and pushes it across.
Okay, because it allows as many users as there are available. So if there's more data, it will try to push it through. So it will use the line a bit better. It might provide worse quality or slightly less quality, not as fast, but it will certainly try to utilize the lines more. Okay, what was your question? Okay, anybody has any question about this previous lecture? Yeah? No, you can't give it to me. You can email it to me if you have no access to Moodle. But if you have access to Moodle, that's your only way of submitting it, is through Moodle. Do you have access to Moodle?
I have, yeah.
Well, log in, open the page, the course page, and you'll find two links. One link that has the file. You can download it, fill it, and then there's another link for uploading. Okay? I'll be back to you.
Which network acknowledges packets?
Acknowledges packets?
Yeah.
Which? That's a very good question, yeah? Anyone? The virtual circuit.
But on both of them, because with additional service, the data link can also do
Yes. Okay, no, with additional service he could do it. But if we are talking about the basic technique, virtual circuit is built and designed to give acknowledgements and to do error detection. But you can, if you want, build extra applications that will do on any network. But we're talking about the basic technique. The datagram switching technique, in its basic format, it does not give you error detection or acknowledgement. But something is built on top of it, the TCP, which will do that. But we're talking about the IP, the original datagram switching technique. Okay, so that's like, okay. What's your question? Okay.
I answered yes.
Yeah, absolutely, yeah.
Yes.
Okay, you're right, yeah, okay. With circuit switching, we said all the circuit switching network does is connects the source to the destination to what seems to be one full circuit. It's up to the sender and the receiver to to send or download their information. They can just stream it. They can break it into packets. It's not a requirement for the circuit switching. Circuit switching doesn't tell you how to do it. All it does, it'll say, I'll connect your computer to the other computer in Canada or Australia, as if they're directly connected on one physical link. So there's no requirement. But most computers, if they do use the circuit switching, they still break their data into packets. But it's not a requirement. So if you had answered yes, we break it into packets, and we send it, that will be acceptable. But as long as you know that the circuit switching does not say you must do it. But if you are giving a route using the circuit switching, a particular route from one device here to another device somewhere else, and if it says you must follow this route, in circuit switching, you cannot change it. All data must follow this route in circuit switching, a must. In datagram switching technique, packets can go this way, and parts of them can go in another direction. Or maybe they will all follow the same route if this route is found to be the best right through the communication. So in datagram switching technique, they don't all have to follow the same route. Maybe they may follow the same route, or they may not with datagram switching technique. But with circuit switching technique, they must follow the same route. With virtual circuit, also, once we select what route you'll follow, all packets will follow the same route. So wherever there is either circuit or virtual circuit, all packets must follow the same design route. Yes? Is it what? It used to be used. It may still be used. You see, circuit switching was used in the old telephone systems. Now most telephone, in some countries they probably still are, circuit switching technique with the old switches. And when they were used with computers, they came up with small devices called modems that you plug into your phone and to your computer, and it will change your digital signal into analog signal, and it will be able to communicate with another computer somewhere else that has a modem as well. So you can, probably they're not widely used nowadays, but I'd imagine in some countries they're still being used. You know, they're about 20-year-old technology at this stage.
Another question, please.
Yeah. Which question? Let me just say the question. The question is, what's the fastest way to download or send a message? Which of those three switching techniques?
People will think that so
That's-
many users.
No, that's correct. So because the link is dedicated, then it is the fastest way to, there's no restriction, there's no sharing, it's all yours. So, but provided you ignore the call setup stage, that will be a fast way. So in large messages that would take half an hour or an hour to do, the call setup stage would be so insignificant, like take a few seconds. But if the message is just one message of one packet or two packets, then it may not be the fastest way. Yes, the line will offer you great speed, but at the time you get that great speed, you'd have spent a second or two in setting up that line. And in a second or two, you can transmit 10 million bits of information. So it would be the fastest, provided we ignore the call setup delay. Yeah, 1 second. I come back to you. Yeah?
4 questions. Call setup, data transfer, and call clearing. Which one is that?
Say again?
Call setup, data transfer, and call clearing.
These are the phases that you must go through in order to do virtual circuit or circuit switching. So you don't do it in Datagram. In Datagram, there is no call setup.
Which packets arrive out of sequence?
Okay. All right, guys. The tutorial deadline is not on yet, so I can't give you all the answers until 5 to 12 tonight. So only if there's something not clear, but I'm not going to be giving answers to tutorial questions now. Yeah.
If there's an error during data transmission on the circuit switching, it drops the call. On the virtual circuit, what happens if there's an error?
Okay, the question is not an error. If there is a link breakdown, you mean, or an actual error in transmitting data?
An error in transmitting data.
No. Yes. Circuit switching Circuit switching technique does not cater for error detection of data. Also, datagram switching technique in its basic format does not provide error detection. So the error just goes. Even if the message is not delivered, it just doesn't tell you, and the sender does not know whether the message has been delivered or not. In virtual circuit switching technique is the only one that provides you with error detection and acknowledgement, and maybe retransmission. You can do it on the other ones. You can add in your own applications, but we're talking about the basic service provided by the technique. Yeah, go on.
Number 12, suitable for remotely live video and sound music over the net. This is, but I want to check about this, about circuit switching, because sometimes we use ISDN.
Absolutely.
For a good quality.
Yeah, the question here says, which one of those switching techniques is more suited for video and sound? And just the question specifies video and sound, indicating that we are looking for good quality. We want no interruptions. So you must pick the switching technique which provides or guarantees quality of service. I won't tell you which one.
Switching is the fastest way to send a message, provided there's no call setup delay. But so usually will be a call setup delay, will there? So is the datagram be the fastest?
If we can ignore it, but no. If we're, hold on, I have a question there. Right, guys. Okay, the question is, which one is the fastest way? And this guy is not quite convinced that circuit switching is the fastest way because of this call setup. See, sometimes you call in the morning and you don't hang up. So then if you want to download a file, the call setup is already done for you. And that's the same with virtual circuit. You can open the virtual circuit in the morning and don't close it till 5 o'clock when you leave in the office. You're already connected to the other computer in Australia, and you don't need to do the call setup again.